Section 6.1 Interactive Assignment Objective 3. In the probability distribution to the right, the random variable x represents the number of marriages an individual aged 15 years or older has been involved in. We're going to complete parts A and B. Now the first question is asking us to verify that this is a discrete probability distribution. So I have this table here, and again it says, in the discrete probability distribution, the sum of the probabilities must equal 1, and all the probabilities must be between 0 and 1 inclusive. Well, if we look at each of the probabilities, 0.268, 0.577, 0.127, 0.022, 0.005, and 0.001, all of those probabilities are between 0 and 1 inclusive, so it satisfies that part. Now, if we take the second part now, because we know that all the probabilities are between 0 and 1. Now we want to be able to determine whether the sum of the probabilities must equal 1. So when we add each probability, we get a total of 1. So far, we have determined that it satisfies the discrete probability distribution. Now the next thing we want to do is we want to draw a graph of the probability distribution and then describe the shape of the distribution. Okay, so the first thing we need to do is the following. Okay, the probability is going to be on the vertical axis and the number of marriages are on the horizontal axis. And so each is going to be considered an ordered pair. So we have 0 and 0.268. So we plot the point 0 and 0.268 and then we draw a line up to it. Okay, likewise, we do the same thing for the next point, 1 and 0.577. So this is the ordered pair, and there's the point, and there's a line that goes up there. And then the same thing, we have the ordered pair 2 and 0.127. And then we have 3, 0.022. And then we have 4, 0.005. And 5 and 0.001. Okay. Now let's just go back into our assignment here. So again, we know that the first part was the fact that the discrete probability distribution, because all of the probabilities are between 0 and 1, and the sum of the probabilities is 1. Okay, now we need to check out what the graph looks like. Okay, so if we're picking our graphs, then we have to choose the one that looks the closest to that. And we can see that B represents the closest one. But let's verify that using Statcrunch. So we're going to open this up into Statcrunch. Okay, now if I want to graph this, what I want to do is I'm going to go to Stat and then Calculators, and I'm going to scroll all the way down to where it says Custom. Now, in the values in, it's going to be the X variable. In the weights in, it's going to be the probability, and then we're going to select Compute. And then you can see that our graph is going to match the graph here for part B. So I'm going to copy this graph and also bring this one to where we're working at right now. Okay, so there is our graph. Okay, what we just graphed on Statcrunch. Now the next question is asking us to describe the shape of the distribution. Now it says if a data set has 2 modes, we would call that bimodal. If a data set has 3 or more modes, we would say that it is multimodal. If it was uniform, it would be all together. So when we look at this graph, okay, we need to take a look at this graph and see what's happening. Okay, so when we look at this graph, we see that the graph, okay, starts here, okay, and then it goes up, and then it's going to go down, and then it's going to go all the way down here. Okay, so what this means is it peaks one time, and if it peaks one time here, then we're going to say that this has one mode. Okay, now if the tail to the right of the peak of the distribution is longer than the tail to the left of the peak of the distribution, then the distribution is skewed right. If the tail to the left of the peak is longer than the tail to the right, then the distribution is skewed left. And if the tails are of equal length, then the distribution is symmetric. So by looking at our graph, okay, and again, I'm just going to go ahead and graph this here. We can see that we have one peak. And what else do we know? Well, we know that the distribution has one mode, So it's one peak and it is skewed right. And let's verify our result. So there's our graph B. And then we can see that the shape of the distribution has one mode and is skewed right.